Hello. We're going over assignment 20, question 9, which asks for the structural formula of trans-3-heptene and cis-3-heptene. So directly from the name, you know that there are 7 carbons in the chain. And so if I were to draw them out, I'll do it this way first. 1, 2, 3, 4, 5, 6, 7. And the 3-heptene means that that double bond is on carbon number 3. 2, 3, we have a double bond. And now we're either doing the trans or the cis version of this molecule. So the difference between trans and cis, first of all I want to get at is hybridization, because that'll get us to geometry. And then from there, we'll be able to see the differences a little bit better between cis and trans. So remember, cis and trans means that either both large groups on either side of the double bond are found either on the same side or on opposite sides. Okay? So in this case here, I'm going to draw the trans version first. I'm going to put these extra H's like that. Remember, each carbon needs to have 4 bonds to it, so I had to add an H here, add an H there. And of course, you're going to have CH2, CH3, CH2, CH2, CH3. So the rest of it doesn't really matter. Now it's all about how this is spread out. When you have a double bond on the carbon like this is an sp2 center. So if you remember your hybridization from first semester, it's all about how many electron groupings or how much space do you need around that metal center for either an atom or a lone pair. With carbons, you don't really have these lone pairs in these particular situations. So you're really just looking about atoms. So you'd have one thing over here, right, one orbital, needs to take up some space here, one for H, and one for this ethyl group here. So this double bond counts as one area of space, if you will, where we need to have that space. So you have 3 things coming off of that carbon, really. So that means you need to involve 3 orbitals in that hybridization. You always need to add your S, and then you mix 2 P's in there, so we get sp2. And the geometry about that, using your VSEPR, is going to be trigonal planar. Okay. So if we were to redraw this now as C, knowing it's trigonal planars, remember this is totally flat, right? 120 degrees around between each bond, planar as it's drawn right there. So now if we were to put things on, if I were to put my large group, so it's this one right here, and I'm just going to draw it instead like that. So there's 2 carbons, 1, 2. Yeah, it can be drawn like that, that's fine. And then over on this side, I have 1, 2, 3. So 1, 2, 3. And then I have H's like that. Okay, this is the trans. So trans means that these 2 larger groups are located, if you think of above and below this double bond, they're opposites, they're on different sides. So one is in above on one carbon and one is below on the other carbon. Now the other version, I'm going to erase it here. If we were to think of the cis one, and I'll draw it instead, just like the stick version of this. Okay, so there's a stick version. Cis now, both large groups are located on the same side of the double bond. And you do get this kind of difference. You get almost a C shape here, if you will. And if I were to redraw this one here, stick style. Okay, there's trans. Here is the cis. So you really see this nice linear, the trans, and here it's not really linear. Well, okay, a long scheme it is, but you end up with more of this C shape to it. So C for cis, if you want to remember it that way. But those would be the 2 differences for this question.